Our next topic is going to be recursion. You might know the Google Easter egg, which if you type in recursion in the search box, it's going to say, "Did you mean recursion?" And then you can click on it, which will make you search for recursion again and have the suggestion, "Did you mean recursion?" Recursion is a method that calls itself. It's quite easy to make a method that calls itself, but making one that is actually going to work and do something useful is not quite as easy. If you want your recursive method to be purposeful, you can't call the exact same method once again. You're going to have to change a little something, or else it's going to end up being an infinite loop. So this method, for example, public void recur, which contains only recur, would be a textbook infinite loop. So every time you call recur, it just calls itself again, and it's never going to end. Simple recursion is a form of recursion which calls one other version of itself. So a method will call itself one more time. An example of this is calculating powers, for example. You could have a method public int pow of int x and int exponent. So x is the number which you will raise to a power, and x is its exponent. So here you know that if the exponent is equal to 0, the result is just going to be 1. In any other case, you know that the result is going to be x times x to the power of 1 less than what it was. So this works because, for example, 2 to the power of 3 is 2 times 2 to the power of 2, which is the same thing as 2 times 2 times 2 to the power of 1, which is the same thing as 2 times 2 times 2 times 2 to the power of 0. So this is why powers lends itself well to recursion. So let's say we were to call pow on 3, so calculate 3 to the power of 3. That would return 3 times the power of 3 to the power of 2. So we've removed 1 from the exponent, which would in itself return 3 times 3 to the power of 1, which would return 3 times 3 to the power of 0. Here, our little method pow knows what 3 to the power of 0 is. It's just 1, so it returns that to the previous method, which can then calculate 3 times 1, which is 3, and return that to the previous method, pow of 3 to 1. And so now power of 3, 2, can calculate 3 times 3, which is 9, and return that to the 3 to the power of 3 method, which will then calculate 3 times 9 is equal to 27, and return that. The case in which the computer knows what to return, the most simple version of the problem, which doesn't cause another recursive call, is what we call the base case. So in this case, if it's the exponent equals to 0, that's the base case. That's when the computer knows what the answer is. Then there's binary recursion, in which the method calls two versions of itself when it runs. A good example of this is calculating Fibonacci numbers. Each Fibonacci number is the sum of the two previous Fibonacci numbers. So 1 and 2 are just 1. And then the third Fibonacci number is 1 plus 1, so 2. And the fourth Fibonacci number is 1 plus 2, so 3. And then the fifth one is 2 plus 3, 5. And the sixth one is 8. You see the pattern. A method that would calculate Fibonacci numbers could go something like this. Public int fib int n, so n will be number of the Fibonacci number which you want to get. And so you know that if n is 1 or 2, you can just return 1 because the first and the second Fibonacci numbers are both equal to 1. If not, you can just return the Fibonacci number of n minus 1, so the Fibonacci number before the one you're looking for, plus the Fibonacci of n minus 2, which is 2 before. So this is the sum of the two previous Fibonacci numbers. So let's say you call Fibonacci of 4. The computer doesn't know what the Fibonacci of 4 is, so it would simply say that the result of Fibonacci 4 is Fibonacci 3 plus Fibonacci 2. Then Fibonacci 3 doesn't know what it is either, so it just says that it's the sum of Fibonacci 2 plus Fibonacci 1. Now, Fibonacci 2 knows that it's 1, because if you're looking for the first or the second Fibonacci number, it's going to be 1 by definition. And Fibonacci 1 also knows that it's 1. So they return 1 plus 1 to Fibonacci 3. So now Fibonacci 3 knows that its value is 2. And it's going to add that to Fibonacci of 2, who knows that its own value is 1. So that will give 3, and Fibonacci 4 can return 3. For Fibonacci numbers, the base case is when you're looking for the first or the second Fibonacci number. That's when the computer knows what the answer is. And it can return a number without making a recursive call. As a summary, a recursive method is any method that calls itself with slightly modified parameters, because a method that calls itself unchanged is pointless and infinite. You're very likely to get a Stack Overflow error at some point in your experiments with recursion. That means that too many instances of the method have been called and the computer simply can't deal with them anymore. So that is often a symptom of infinite recursion, although depending on the problem you're trying to solve, it might just mean that you need a different technique. So recursion lends itself to solving problems that can be divided into smaller but identical problems, like calculating powers or Fibonacci numbers.